Alright, so in this video I'm going to show you how to solve a system of 3 equations, 3 unknown variables. I'm going to be going over my number 2 problem, and I'm just going to kind of go through each of these boxes. So it says write original equations in this box. So I have negative 4x minus 2y plus 3z equals negative 18. And I always double check my signs because for some reason that's where I make my errors when I copy down problems. So I have negative 4x minus 2y plus 3z equals negative 18. Good. So I double checked there. Then I have negative x minus 3y minus 3z equals positive 13. Again, double check. Negative x, negative 3y, negative 3z, and 13. Good. Next equation is 3x plus 5y plus z equals negative 7. Quick double check. Positive 3x, positive 5y, positive z, negative 7. So the reason I'm really double checking to make sure I didn't make any errors is if I made an error in writing the question, I'm going to do all this work for no reason. So you make sure you write the correct equation. So here I am going to number my equations, and then I'm going to go into step 2. It says eliminate a variable. So I'm going to look at my equations, and I see that it's fairly easy here to eliminate my z's. You see that? And then I look at another one because I know I'm going to have to use 2 different equations to eliminate the same variable, because I'm looking over here at number 3 where it says eliminate the same variable. So it looks like z is pretty easy to eliminate. It looks like here the coefficient of x is 1, so I could multiply by a negative 4 here, and I would get opposites here, or I could multiply by a 3 and I would get opposites here. So it looks like my x's or my z's are pretty easy to eliminate, but since my z's are already set up to eliminate here, I'm going to do that. I'm going to eliminate variable z, and to do so I'm going to use equation 1 and equation 2. So I have negative 4x minus 2y plus 3z equals negative 18. Negative x minus 3y minus 3z equals 13. And again, I always double check my signs, so I'm just going to quickly go negative, negative, positive, negative, good, negative, 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 positive. Okay, so I double check my signs because I don't want to make any errors. And I'm going to eliminate z like I said I was going to. So I get negative 5x minus 5y equals negative 5. And I'm going to number this equation number 4. This is the new equation that I got. So I'm going to move on to step 3, and it says eliminate the same variable, which was variable z. So I can't use the same 2 equations. If you look over here, I already used equations 1 and 2. So I have to use 2 different ones. And not 2 different ones, I just mean if I use 2 again, I cannot use 1 because that would be exactly what I have over here. So I'm going to use 2 and I'm going to use 3. And I'm going to eliminate z there. So equation 2, I don't have to multiply anything by, but for equation 3, I need to multiply by a 3. And I'm doing that because I want to get a positive 3z here so that my z's will cancel. So again, equation 2, I'm not multiplying by anything, so I'm just copying down my equation. And then equation 3, I did multiply by something, so I'm going to get 9x plus 15y plus 3z equals negative 21. And eliminate z like I said I was going to. So 8x plus 12y equals 8. Oh, make sure you double check your signs there. That should have been a negative, right? A negative 21 plus 13 is a negative 8. And again, I'm going to number this equation because this is my next equation. So I have equation 4 and equation 5. And it says, combine these equations to eliminate another variable. So let me bring this down here. I have negative 5y minus 5y. Oh, I just realized I made a mistake. Copying the question down wrong. So I have negative 5x minus 5y. There we go. Equals negative 5. And I have 8x plus 12y equals negative 8. So I'm looking at my coefficients here, and I have 5 and 8, and I know that both of those numbers go into 40. And I'm looking at 5 and 12, and I know both those numbers go into 60. So I think I'm going to eliminate my x's in this case. So I'm going to multiply the top equation by 8, and my bottom equation, oh, not by negative 5, but positive 5, because I want them to have opposite coefficients. So I need one to have a negative 40 and one to have a positive 40. So I'm going to, had I written just a little bit smaller, I probably could have fit it in right here. But since I didn't, I'm just going to use the space off to the side here. So I get negative 40x minus 40y equals negative 40. And this bottom equation, when I distribute, I'm going to get positive 40x, positive 60y equals negative 40. So doing elimination, x's eliminate, y's give me a 20y equals negative 80, and so I get y equals negative 4. So I'm going to write that in here, y equals negative 4. And that writing's just a little sloppy, so I'm going to make it just a little neater. So y equals negative 4. So if I look at step 5 here, it says substitute back into one of these equations. And it should say to find the other variable. So take this negative 4 and plug it into one of these for y and find your x. So that would look like negative 5x minus 5 times negative 4 equals negative 5. So negative 5x plus 20 equals negative 5. And if I subtract 20 to both sides, negative 5x equals negative 25. So x equals positive 5. Okay, and it says for step 6, solve for remaining variables. So let me go up to my original equation here. I have x and I have y that I found. I have not found z. So I can plug it into any of these three equations. I'm going to plug it into equation 3. So that's, what was it, 3x plus, is it 5y? Let me go up and look. Yes. Plus z equals negative 7. So I'm going to plug in the values that we've got. So I've got negative 4 for y, and I have positive 5 for x. And that will give me 15 minus 20 plus z equals negative 7. So if I keep going, I'm going to get negative 5 plus z equals negative 7. Add 5, and I get z equals negative 2. So step 7 says, if there is one solution, write the ordered triple format If not, circle one of the others. So it's not no solution, it's not infinitely many. We did find a solution, and it's really important that you put these alphabetical order. This is X, this is Y, this is Z. That's why it says write it in order triple format, because it needs to be correct. It goes 5, then -4, then -2. And that is my solution. So I'm going to do another example so that we can get some extra practice with this. So let's do another example. Example 3 is the next one that I'm going to do, and that is x minus 4y minus 3z equals -14, -5x plus 2y plus 3z equals 16, and -3x minus y plus 3z equals 3. And so I always number my equations, equation 1, equation 2, and equation 3. So step 2 says to eliminate a variable, and I see that my z's already have opposite coefficients, -3z and +3z, and -3z and +3z. So I'm going to eliminate my z's. That seems to be the easiest one to eliminate. And I'm going to take equation 1 and equation 2, and equation 1 and equation 3, and I get x minus 4y minus 3z equals -14, -5x plus 2y plus 3z equals 16, and over here x minus 4y minus 3z equals -14, -3x minus y plus 3z equals 3. And there's nothing that I need to multiply in order to eliminate z's because they already have opposite coefficients. And so -4x minus 2y equals 2, and that's equation 4. And over here the same thing, already have opposite coefficients. -2x minus 5y equals -11, and that's equation 5. So if I combine these two equations, I have -4x minus 2y equals 2, and -2x minus 5y equals -11. And it says combine these equations to eliminate another variable. So I'm going to eliminate my x's by multiplying by a -2 here. And so when I do that, I have -4x minus 2y equals 2, and the bottom equation is 4x plus 10y equals 22. So x's eliminate there, and I get 8y equals 24, so y equals 3. And once I get that, I just look at step 5. It says substitute back into one of these equations to find another variable, right? So I have -4x minus 2 times 3 equals 2. And so -4x minus 6 equals 2. -4x equals 8. So x equals -2. If I plug that back into one of my original equations, let's say equation 1, which is x minus 4y minus z equals -14. I would have x is -2, y is 3, and I could solve this. Let's see, -2 minus 12 minus 3z equals -14. -14 minus 3z equals -14. If I add 14 to the other side, I'm going to get -3z equals 0, and I can divide by 3, not by 0, but I get z equals 0. So my answer is -2, 3, and 0. And tomorrow we'll talk about what it means to be no solution and infinitely many.